The night sky has captivated humanity for millennia. We gaze upwards, drawn to the twinkling stars and the silvery glow of the moon. But there is a celestial display that surpasses all others in its ethereal beauty, the aurora borealis, or northern lights. Imagine standing beneath a sky ablaze with vibrant hues of green, pink and purple, dancing and shimmering like celestial flames. This breathtaking spectacle is not a figment of fantasy, but a natural wonder, visible on a clear night in the northernmost reaches of our planet. For centuries, the northern lights have been a source of awe and inspiration, woven into the mythology and folklore of cultures across the globe. In Norse mythology, the aurora was believed to be the shimmering armor of the Valkyries, female figures who decided who lived or died in battle as they rode across the sky. The Inuit people of Alaska saw the lights as the spirits of their ancestors, dancing and playing games in the heavens. Seeing the northern lights is a truly unforgettable experience, a chance to witness the raw power and beauty of our universe firsthand. So, if you ever find yourself beneath a dark, clear sky in the northern latitudes, take a moment to look up and marvel at the celestial ballet of the aurora borealis. The aurora borealis, while appearing magical and otherworldly, is actually a scientific phenomenon, a breathtaking display of light caused by the interaction of the sun and Earth's magnetic field. The sun constantly emits a stream of charged particles known as the solar wind. This wind travels through space and interacts with Earth's magnetic field, a protective bubble that surrounds us. Earth's magnetic field deflects most of the solar wind, but some particles become trapped and are drawn towards the poles. When these charged particles collide with atoms in Earth's upper atmosphere, they transfer their energy, causing the atoms to become excited. As the excited atoms return to their normal state, they release energy in the form of light, creating the mesmerizing colors of the aurora. The color of the aurora depends on the type of atom that is excited and the altitude at which the collision occurs. Green, the most common color, is produced by oxygen atoms at lower altitudes, while red and blue are produced by oxygen and nitrogen at higher altitudes. Understanding the science behind the aurora only enhances its beauty, revealing the intricate workings of our universe. Tonight, March 4th, 2025, presents a rare opportunity to witness the celestial magic of the northern lights across the northern United States. A minor geomagnetic storm, a disturbance in Earth's magnetic field caused by solar activity, is predicted, increasing the likelihood of aurora sightings. This storm, measured by the KP index, is expected to reach a level of 5, indicating moderate geomagnetic activity. The higher the KP index, the stronger the geomagnetic storm and the greater the chance of seeing the aurora at lower latitudes. While Alaska always boasts the highest likelihood of aurora sightings, residents of states like Washington, Idaho, Montana, North Dakota, Minnesota, Wisconsin and Michigan have a good chance of catching the show tonight. Even those in Wyoming, South Dakota, Iowa, New York, New Hampshire, Vermont and Maine might get a glimpse if conditions are favorable. The best time to catch the northern lights is typically between 10 p.m. and 2 a.m. local time, when the sky is at its darkest. However, auroral displays can occur at any time, so it's always worth keeping an eye on the sky if you're in a location known for aurora activity. Remember, seeing the northern lights is never a guarantee, as it depends on a combination of factors, including solar activity, weather conditions, and light pollution. However, with a bit of luck and planning, you can increase your chances of witnessing this unforgettable natural wonder. So check the latest aurora forecasts, bundle up, and head to a dark location away from city lights. You might just be rewarded with a view of the northern lights dancing across the night sky. Section 4. Finding the perfect vantage point. To maximize your chances of witnessing the northern lights in their full glory, choosing the right viewing location is crucial. The key is to find a spot that is as dark as possible, minimizing light pollution from cities and towns. Seek out remote areas away from urban centers such as state parks, national forests or open fields. If you're in a coastal area, try heading towards the coast, where the reflection of the aurora on the water can create even more spectacular views. Once you've found a dark location, look for a spot with a clear view of the northern horizon, as this is typically where the aurora will be most visible. Elevated areas such as hills or mountains can provide an even better vantage point, allowing you to see the aurora above any potential obstructions on the horizon. Before you head out, it's a good idea to check the weather forecast and dress warmly, as clear skies and cold temperatures are ideal for aurora viewing. Bring along a red flashlight to help you see in the dark without affecting your night vision. Section 5. Capturing the magic photography tips for aurora hunters. Photographing the northern lights can be a challenging but rewarding experience, allowing you to capture the ephemeral beauty of this celestial display and share it with others. To capture stunning images of the aurora, you'll need a camera that allows for manual control of settings, such as aperture, shutter speed, and ISO. A wide-angle lens is ideal for capturing the vastness of the aurora and its sweeping movements across the sky. A sturdy tripod is essential for keeping your camera steady during long exposures, which are necessary for capturing the faint light of the aurora. Use a remote shutter release or the camera's self-timer function to minimize camera shake when taking your shots. Set your camera to manual focus and focus on infinity to ensure that the stars and aurora are sharp. Experiment with different aperture and shutter speed settings to find the best balance between capturing the detail of the aurora and the surrounding landscape. Start with an aperture of f/2, 8 or lower, and a shutter speed of 10 to 20 seconds, adjusting as needed based on the brightness of the aurora. Section 6. The solar maximum, a time of enhanced aurora activity. The Sun, our very own star, goes through a cycle of activity that lasts approximately 11 years. This cycle is marked by periods of high and low activity, characterized by the number of sunspots, solar flares, and coronal mass ejections. We are currently in a period of increased solar activity known as solar maximum, which is expected to peak in 2025. During solar maximum, the Sun's magnetic field is more active, leading to a greater frequency and intensity of solar flares and coronal mass ejections. As we approach the peak of the current solar maximum, we can expect to see more frequent and intense aurora borealis activity, even at lower latitudes than usual. This heightened activity presents a unique opportunity for aurora enthusiasts to witness the celestial spectacle in all its glory. Section 7. Beyond the lights, understanding geomagnetic storms. While the aurora borealis is a beautiful and awe-inspiring phenomenon, it is also a visible reminder of the powerful forces at play in space and their potential impact on our planet. Geomagnetic storms, like the one predicted for tonight, can cause more than just stunning auroral displays. These disturbances in Earth's magnetic field can disrupt radio communications, GPS systems, and even power grids. During a geomagnetic storm, the influx of charged particles from the Sun can interfere with radio waves, causing disruptions in communication systems that rely on these waves. While the geomagnetic storm predicted for tonight is relatively minor and not expected to cause significant disruptions, it serves as a reminder of the importance of space weather forecasting and preparedness.